Hello, everyone. Thank you for attending today. And before we get started, may I see some comments in the question box that you hear me and that you see my screen with slide deck? Okay, thank you. So continuing on the topic of Vlingo as our reactive platform, I'm going today to jump in, sort of in the middle of things, assuming that many of you have already attended one of the webinars. So if not, there are other recorded webinars on my YouTube channel that you could go and kind of get some reruns from previous weeks. And I think this is maybe our 7th or 8th webinar on Vlingo. So to jump into the subject, Vlingo is a DDD-friendly reactive platform. What does that mean? Well, it means that we are first and foremost a reactive platform, but we also make it quite comfortable for anyone that's using DDD in a contemporary way to model their domain in a Vlingo world, what's called a Vlingo world. And actors, which is the level of abstraction that we use for objects, are asynchronous, concurrent, and depending on the number of processors you have running on a server, for example, also parallel. And this is because of the message sending capabilities of actors. So you can think of actors like objects, but objects that have messaging between them, and it's asynchronous messaging. So one actor sends a message to another actor. The actor that sends the message continues to run. The actor that has been sent the message will run and receive that message when there is a thread allocated to it. And this is all based on, roughly the principles of, task switching and so forth. The actor who has sent a message will very soon be able to process that message. And Vlingo is a type-safe actor model, which means that any message that is sent to an actor looks like a regular method invocation with all types being safely checked by the compiler. And that's because every actor implements at least one protocol, and the protocol is what the client of the actor, that could be a regular Java object, for example, or another actor, they only know about the interface or the protocol that the actor supports, and so they invoke messages or methods on the interface, and that interface in the background inside that specific implementation that they have turns that method invocation or reifies that method invocation into a message that's put into the actor's mailbox. Okay, and then with Vlingo, what you'll see today is that we implement most of the patterns in tooling that would typically be used on a modern DDD project. Okay, and one of those things that we'll talk about today is within a, let's say, microservices environment, Vlingo can talk between different services. Here you see a rate service and a risk service. And the rate service is, for example, calculating the rate of an insurance policy, and the risk service is providing risk information based on the application that the rate service is currently providing a rate for. So there has to be some sort of interaction between these two. And So when they interact, what we're going to look at today is an example of REST, using REST for the rate service. As a client, you see the circle in the rate service. This represents an actor that is a client of the risk service, and the client speaks HTTP to the risk service, and there is a resource, that's the R in the risk service. This represents a RESTful or REST resource, and this receives the method invocation of the kind of request that has been sent. So for example, post, put, patch, whatever that happens to be, will be translated into a method invocation, but through an actor. So again, completely asynchronous on the risk service side, and then the resource talks to an entity in the domain model. And notice we're cutting out a layer there, so no need for application services to manage the task and the transactions, because that's all taken care of in the domain model. And so this is mainly what I'll be demonstrating today. But also, the domain modeling is handled through different kinds of entities, and the 3E actors that you see here are 3 different kinds of entities. One could be, for example, an object-based entity, which means that it's backed by an object store. So JPA, OR mapping kind of backend for this one. The entity in the middle is an event-sourced entity and has a journal behind it, and the entity behind the on the right-hand side has a state store, a key value store behind it. So 3 different flavors of the kinds of persistence, and then a number of different persistence engines or databases that are available behind those actor interfaces that are the object store, the journal, and the state store. And notice that the object store and the state store both also support journals, so you can persist along with the state of your object, or the key value of your state domain events, for example, into a journal, and that's all transactionally persistent. And the persistence is automatically handled. I'll show you that today. You don't have to worry about any of the persistence details after the service is bootstrapped. Okay, and so actually, let's just roll back, and we're going to talk about this first. So let me go over to my demo environment, and let's start with this hello. And I want to show you first, actually, that hello world is available at github.com/Vlingo/Vlingo-hello world. And this is, if you go to the home of github.com/Vlingo, this is the JVM version of Vlingo. We also have a .NET version, but I'm going to stick with the Java version today. And Vlingo Hello World is a pinned repository at the upper left, so you can find that very easily. Okay, so what we're going to do is we're going to walk through this example, Vlingo Hello World, and for a Hello World example, it's actually fairly, does enough to fully demonstrate much of the Vlingo platform. So it's not just a simple, hit a URI and there you get your hello world back. We will show you that, but there's a bit more to it. So let me start with the information. about a hello resource. So notice in the architecture, this is sort of what we would call the service level package or namespace. So IO Vlingo hello, that represents what is this service. And then resource is architecturally in the port adapters. So if we're using hexagonal architecture, you would see this resource area as part of the adapter part of the ports and adapters architecture. Okay. Now notice that the hello resource doesn't have to implement any specific interface. It doesn't have to extend an actor type or anything. It's a simple POJO. And then you're wondering, okay, how does this POJO actually work when it comes to handling requests? Okay, well, notice that we have two request handlers. One is hello and one is hello whom. And hello is just going to reply hello world or create a response with hello world. And the hello whom is going to use a specific name of some kind. Whom are we saying hello to? And notice that hello simply uses hello whom and passes it world. So by default, we're going to see that. And then the hello whom responds with a completes with success response of okay, hello world, okay? Or in this case, hello whom. Now, how does this all wire up? Very simply, there is a routes method that answers a resource. And this resource is initially created as a hello resource, and we have a get. We're going to here handle a get request, so the HTTP get method, and this will map to our web server or a REST server as /hello, and this maps to the hello method, as you can see here. So when I highlight that, it maps to this hello, and then we have a separate get method handler which maps to hello whom, and this of course is the parameter that gets passed in. And so you can see that we have a parameter of type string, and we handle this in the hello whom method. So you can see here that that method is highlighted. So let's just initially switch over here to our demo environment, and let me see here. Let me make sure that the server is running. Where is it? Where did you go? Oh, there we are. Okay. So let me just, so we're going to build simple, let's see, Maven clean package. Okay, so let's build that. Okay, so it's using the Vlingo platform, jar files, artifacts, and then let's start it using Java jar, and we're going to use the Vlingo hello world with dependencies jar. Okay, so we start our server up. The server's running. You can see how quickly the server starts. Generally speaking, we're seeing, just within a few milliseconds a start. And here we're using info output, but you don't need to, not running at that level, you would have a lot less logging and it would start up even quicker. Okay, so let's just see a simple hello. Okay, so we simply hit localhost with port 18 80 or 18,080 with hello, and we get back hello world. Okay. And we can alternatively say hello/me, and we get back a hello me. So you can see even on cold startup, the service replies very quickly. Let's next look further down the resource. So this is what we've done so far. We simply curled with get onto the hello resource or the hello resource with a parameter me. Okay. So this is using, as I showed you before, the hello resource. Would you say that's fairly easy? Simple, at least? I think you'll be quite happy with that. Now, let's go into a bit more advanced example. This is a greeting resource, and this greeting resource it has a few more actions related to it, so the resource itself can do more things. So let's take a look at this greeting resource in code. So this is just like follows the same basic pattern of the hello resource. We see here as we did with so notice that we don't even have a constructor for hello resource. This resource doesn't need the actor world, but this resource, when we create it, we're going to pass in to the constructor a world. This is the Vlingo world. This is the highest level abstraction in the Vlingo platform, and this is the world that actors run in. It's the world that everything runs in on a single JVM. Okay. And we're also going to ask the world for its address factory. That is because actors are at addresses, and we're going to use the address factory to look up existing actors or to create them if they don't exist. And I'll show you that in a moment. And then we also have, we're going to start up our query model, and the query model is instantiated, and we hold a reference to our query model. So the very first thing that we want to do is define a greeting. And notice that the greeting, defined greeting, receives a greeting data type. This is simply a data object. You might call it a DTO if you'd like, but it's just a data object. And this is what, let's say, the REST payload or the body of the REST request that is a post will have a JSON data type or JSON serialization, and we will automatically map that JSON into a greeting data object. And then what we do is we use the greeting protocol with a static method on that protocol or the interface, and we tell that that method to define a new greeting with a message and a description of that message. So whatever gets sent in as a JSON object in the body of the post request is mapped, and we're going to relay that information in to the definition of a greeting. Let's just look internally at that briefly, and here's really as simple as that is. The define static method receives a stage. This is the area where actors actually live and run. So the world is the highest level abstraction, but by default it has one stage, and the default stage is where all actors would be created unless you create a different stage. And then we're passing in the message and the description. Notice that we're creating an address in behalf of the actor. And we're asking the world's address factory to create a unique prefixed address. So we're going to put a G for greeting, a G dash in front of all the addresses. This might be helpful for debugging or just for some other reasons for the service's use. And then what we're going to use is use the stage that's passed in to create a new actor for this type, which is a protocol or an interface. And we're going to use the description that we're going to implement that protocol or interface in the greeting entity. And then we're going to pass the address as a parameter, okay, to that to the actor. And then the first thing that we're going to do is send a message to the actor that says define with, and that message is sent asynchronously with the parameters message and description. Okay, so we can expect that in our greeting entity that implements the greeting protocol, that we are going to have a define method, and we'll look at that in more detail in a moment. For now, though, notice that the protocol greeting has three methods, three instance methods: define with, the message and the description, and then we can redefine, as it were, the message, so we can change the message with message, a new message, and we can change the description with description, okay? And I'll show you the use of this enumeration in a moment. It has a specific use through the architecture, and I'll explain that to you in a moment. But this is a simple Java interface that happens to have one static method, okay? So if we go back to the resource, we can see that we can define with, and then notice that if we want to change the message, what we need to do is resolve the actor whose ID is used to describe the ID of the actor's address. Okay, so we're going to, now this is going to be a patch, and I'll show you that down here in the routes. So we have greetings, which is a post, so we can post to greetings, body of greeting data, and we can handle that in define greeting. You can see that handled in this method. Then if we want to patch the message of a given greeting, we use greeting/greeting ID and pass in and resolve to a partial update using patch of just the message part. And this takes a string parameter of the identity and the message data, which is a separate data type, right, that holds the data for this specific request. And this URI maps to change greeting message, okay, and you can see that here. And then we have a different one, greetings/greeting ID again, but this time we're going to do a patch on the description. So we have a parameter of string for the identity, the description data, and then change greeting description is the method that's going to handle that. And then notice finally we have some get methods for queries, so we can query all greetings and we can query a single greeting. And I'll show you how those work. Also notice that the resolve method, which is implemented here, simply takes the greeting ID, asks for the address of the actor, so we can ask the address factory to give me an address from a string identity, and then the actor of method looks up the actor of that specific address that's returned from the address factory, and it says it will have, this is the protocol of that actor that we want to use specifically. And note that if that actor doesn't exist, as in it exists persistently, but maybe it's been evoked from memory because of a high watermark on memory, and now we can just simply say greeting entity is the type in case we need to create that actor. Okay, so we purposely keep the creation parameters very thin, and the initial message is what actually initializes the full state of that actor. But because we're using the resolve in changing a greeting or changing a description, we know that we already have a pre-existing state that has already been defined, whether or not that actor is still in memory. It probably is, but maybe it isn't. And then after we resolve that actor and we get a reference to it that we can send messages, this is the greeting entity that fulfills this or implements this protocol, the greeting protocol or interface, and we send it the message with message.value. So this is the data, the message data that's passed in. That's what this message is. And then after we receive the completion, the indication that this has completed, that is provided by showing us the current state of that greeting, and that state can then be mapped and serialized into the response with an OK based on the greeting data, right? So we're gonna serialize that state as greeting data. Otherwise, if for some reason the actor was not found, does not already exist either in persistence or still cached in memory, we have an otherwise that responds with a not found. Okay. All right, and the same pattern for change greeting description. So first of all, before we look at the entity, let's make sure that this works in our little test here. Let me wind back and find my okay. Here's the post. Looks like my nice terminal window got a little messed up in the prompt, but I'm sure this is going to work. So notice that we got back from this post request with this JSON payload, application JSON content type. We got back a 201 created with a location of greetings/232. So this is actually the address of that actor, which is also its unique identity as an entity. And we also got back the content of that, and that's what was that was the response that you see here, a response of created with the location header, and then also the serialized greeting data itself. Okay. And then you can see that output here. All right, so there's that. And then let's see, what do we want to do next? Let's change the greeting message. So navigate back through there. Where do we have our patch? Which one is this? Oh, sorry, let me see here. Patch, yeah, we're gonna patch the message here. So we patch the message. Recall that before the message was hey, now the message is yo, okay? And then let's patch again, and we're gonna patch the description this time. And just see if I can see this on my terminal. Patch. description. Okay, so we're going to patch the description from says hey to says yo. Okay, so let's patch that, and we see that we get back the fully changed in two different requests, a message with yo and a description of says yo. All right. All right. So now you can see a fairly, basically you would use this pattern throughout. You can map, delete, patch, post, put, any of the HTTP methods can be assembled in the same basic way that you see here. Okay. And now let's look at the greeting entity. The greeting entity is in our domain model. So this is still our service namespace. You could call it the bounded context, although I wouldn't really call this a DDD model, but it is a model. And the greeting entity implements the greeting interface that you saw, which is define with message, and with description. And the stateful entity is extended is extended by the greeting entity, and this stateful entity is a key value store entity. Okay, so it's a very simple interface. The persistence interface is basically give me a key and give me a blob or a clob, and I will save those as one unit in the database. Now notice what we're going to save is not the actor, but we're going to save the actor state. So what is actually persistent is the greeting state. And you can see that the greeting state is quite simple. We have a few different ways to, or actually we have one way to initially construct the greeting state, and that is greeting state has an ID, a message, and a description. And you can see that is used here. So this is where we first create our initial state. So when we exit the greeting entity constructor, our state is still null. And we simply check that here because we want to know, have we already seen a defined with message? And if that's true, we're not going to allow this to be redefined. Define with is an initial interface used by this. And then if we have already seen a define with, we're going to just answer the state that already exists, whatever the current state is. But notice that this is a very simple interface where we take whatever message is incoming, a command message, and we say apply the greeting state that has the ID, and the ID was already provided for us in the constructor, and the message and description. And then notice that we also define what is the operation that just occurred. This is going to be important for our for our CQRS query model projections. So we're going to use that a greeting defined happened, and you can see that the same kind of operation is sent along with the with message and with description outcome, and I'll show you how that works in a moment. But finally, what do we return? How do we return a completes of a greeting state? Well, we do that by passing this consumer, and the consumer basically says, I'm going to take the new state that has just been updated after the apply operation occurs, and I'm going to return that as a completes state out of this message handler. The same goes here, and so forth. Okay. Now, this apply method is actually asynchronous. So when you enter this apply method, there is an atomic transaction that takes place asynchronously with whatever storage you're using. In this case, we're using a state store, which is the key value store behind this. And this happens asynchronously, which means that the return here actually happens before the operation occurs. But because we pass in this consumer, the asynchronous operation that occurs here is after it occurs, then internally we have a completes that gets created and returned sort of, behind the scenes. So this completes that gets returned immediately after the message is sent to the store is sort of empty, right? It's not actually a completed completes yet. Instead, it's waiting to be completed, and inside of the stateful entity, once the atomic transaction occurs where the new state is saved as a key value pair, then the state of this greeting entity will be updated, and you can see where we're told that here. So the stateful entity will call back on this entity on the actual implementation and say, here's your updated state. So by the time this consumer is actually being executed, it can provide the updated state that's given back here. And the only two methods that you have to support in a stateful entity are these two. Take your new state and give me the type of your state. Okay, and this type of state tells the state store basically what table or what collection to save this this entity in, or the entity state in, right? Okay, so we're getting relatively, further along here. I just want to show you that when this entity, after the entity is persisted, another thing that happens, so in every single one of these, define with message, and with description, again, which was sent by the REST resource directly to the entity, to the actor, not only do we have an atomic transaction that takes place for each one of these three methods, but also we're going to use this operation, such as operation greeting message changed and operation greeting defined, in our projection. How do we get the projection actor basically stimulated with new updates? Well, what we do is we say that the greeting projection actor, which is going to project the new changes to the state of the greeting entity, into our query model. And we're going to extend the Vlingo state store projection actor, which provides some really handy behavior. And so, for example, here's the real point of this, right? We're going to merge the existing current data as in the previous data that may have been in the query database previously, based on a previous version, with the current greeting data and the current version. So how do we do that? Well, we're told what is the reason that this projection is currently being used. Well, we get that information from the projectable, and the projectable knows the reason, or the because of, projectable because of, it's projectable because of this particular operation value. And we're going to switch on that because of value that's set here when the merge is invoked by the state store projection actor. And then all that we do is we simply say, okay, well, in the case where it's greeting defined, we have no previous data. We're just going to say that the merged data is the current data. Otherwise, we can merge the previous data ID with the new message. And notice that a message changed count and the previous data description. So the description didn't change. So really what we're doing is handling a merge here, and we do the same kind of merge here, except we're merging in the description changed and change count here with the previous message and the previous ID, okay? And what can we do with that then? Well, let's go back to our README. We've already created our new greeting, and we've also modified our new greeting to have a changed message value of yo and a changed description of says yo. And so what can we do? Well, let's query let's use a query, and you just, oops, pardon me, wrong one. Let's do a get. And let's see here, we don't need our content type. And we don't need a value, but we do need an ID, right? So query that greeting and see what we get. And in fact, we get a 200 OK with says yo, and I'm sorry, the message is yo, and the description is says yo. So that shows the updates all the way around. And I haven't yet shown you the queries actor. This is where we have a, in this case, we simply have one query or two queries provided through the query model. And in this case, also we have, this abstract base type state store query actor, sort of like we have the state store projection actor. And this makes querying really easy. As you can see, we're going to query on greeting of the greeting ID, and we're going to ask for the query of this ID with this type, right? And then if that is not found, we're going to answer an empty greeting. Okay, so if we go clear back to our greeting resource, you can see that when we greet with, or when we query with the ID greeting, we're going to tell the queries protocol, which maps to that actor, sends an asynchronous message to the actor that says greeting ID, uses the greeting ID, and then too, when we receive the answer back asynchronously, right? So we need a pipeline here to deal with that asynchronously, and then we answer with a completes with success response of okay, and we're going to serialize that data. And again, if there's no data, otherwise no data, we're going to respond with a not found. But obviously we found it, and so we hit the second one. Well, that's about a 45-minute presentation. And what I'd like to do now is take questions. If you have questions about this, if you'd like me to walk through some code, so feel free to post some questions. In the meantime, remember that you can find this project at github.com/Vlingo/Vlingo Hello World. Any questions? Can I list all messages? I'm sorry, what do you mean list all messages? Can you clarify that, Anders? You have an API for that. I'm sorry. Oh, I see. So what you're asking is, let's see here. If we go into the projection, right? So we're projecting each one of these, and then what I assume is you're asking, can I project this? So what I've done in this particular example is I've left this as a to-do, but what we would do is we would query, we would say like this, in essence, right? We're going to say store, query store, and we can say stream all. And what we're going to stream all of is this data. And after that, hang on, what I need to do is create an instance variable so I can get to this quickly. And this dot store equals store, right? And then state store. Sorry, let me see what's wrong here. State store reader. Oh, sorry. All of, right? So we stream all of this, and then we say, for example, out of this, we're going to say, and then I'm just having a little visual issues here because of my anyway, I think you see the idea, right? So we just, instead of doing actually a query for everything, we're going to stream instead, because streaming is much more efficient. And then what we're going to do is, once that stream is is realized, then we can map that into a collection and return that. So, but I welcome you to implement that yourself by trying out the Hello World. Should see that is quite simple to do. Okay, let me see here. Richard, can you show how to implement a query by message? Well, Richard, how is that different than this? Query by message. Oh, latency, what you want to see, like if you want to see if I run this under time, maybe, is that what you're saying? So, yeah, I mean, I don't know, is that what you mean, Richard? So basically, no. I sent the question the same time you start. Oh, okay. Oh, latency as in the questions overlap. Gotcha. So I did answer your question then. Yes. Okay. Very good. I gotcha. Okay. Well, I think that maybe one of the main points is just go, you know, clone this hello world. There's a lot of code, as in not a lot of code, but a lot of ideas are explained in this code. In the architecture itself, I know this is probably a little bit thin, or the font is quite small, but you can see under hello infrastructure that we have a persistence. This is where all the queries and all the projection is done. Also under infra is where the different data types are. So the greeting data, this is just simply a, basically a POJO. Oh, and notice the style that I like to use. This is sort of based on the functional programming approach, which is referential transparency, right? So it means that I could have an ID method or I could have an ID value, and you shouldn't be able to distinguish the two. And the fact that this is final means that you can't modify any of these values. So instead of adding a bunch of getter methods, we just simply use a fluent direct access, which in functional programming, again, it may be directly the value, or it may be invoking a method or a function to get that value, and you don't need to know the difference. Okay. One other thing I could show you here is the bootstrap. So this is actually how we start up. There's a bit more, techie stuff in here, but basically, right, we have a main and we have some args, and if we provide a port in the args, we're going to use that port in our HTTP server. Otherwise, we're going to use the default port, which is 18,080, okay, 18,080. And then we create our bootstrap instance, and when we construct that, this is where we create our world. This is where we create like the stateful type registry. This is how the types are understood and exchanged between the command model and the query model and the databases, okay, this kind of thing. And then you can see here we create the two resources. So we create the hello resource with no construction parameters, and we create the greeting resource with the world. And from the world, here we get, some things initialized like our address factory and so forth, right? So where did the bootstrap go? Bootstrap. Yeah, and then we simply start our HTTP server. Start with the world stage that we want that actor, that server actor, to run in, and the resources are, so it takes a vararg list of hello resource and greeting resource. The port that we're going to use, we use default sizing, which is basically how many pooled dispatcher actors do we want to have, how many, this kind of thing, and then define with a time of, what is it here? That is the probe interval between the times that we're going to check for new input from the socket, and then how long we wait for that. So actually there is, in this case, a little blocking in the server, which is up to 3 milliseconds, but that's the way Java, NIO server sockets work. And then the 100 is what again? That is, the timeout. So if a partial HTTP request arrives as bytes, but the HTTP request parser doesn't have a full request, this is the amount of time that the server should wait for that remaining request data to be read out of the channel, or it will time out and throw that request away. You may or may want to adjust that. But anyway, this is the simple bootstrap. You can try some different things, wire in, one thing I can think of, why not implement the greeting entity as a domain, what is it? Event sourced entity. In that case, you don't use this, right? So now we're event sourced. Well, this isn't going to work the same. The apply methods are slightly different for event source, but you can just jump in here and refactor this to an event sourced. And then, of course, you won't use these greeting defined operations. Instead, what will get projected are the events, right? So the projections, your, for example, your projection actor will be acting on projectable data that has events in it, okay? All right, let me see. I think we have a few more questions here that have arrived. How do exceptions, how are exceptions handled? Good question, Ben. So let's look into the greeting resource. So you see, for example, and otherwise here, we also have, okay, let me just, I gotta move things around because my, okay, let's see, so dot, oh man, what was my, oh, I did need that. Dot recover from, right? So what we're going to get here is an exception, and right. So we could say, for example, response of instead of not found, we would say, for example, bad request. Okay, and we might even serialize the stack trace if that's going to help anybody. I don't know, but we could provide some more error information, but that's basically how you would do that then. Hopefully that helped. Anders 18080 super idea. I'm sorry. Anders, I'm not sure what that means. 18080 super idea. Oh, do you mean to use ports 80? Yes, you could certainly do that. You could, if that's what you meant, I don't know if that's what you mean, but you could pass in port 80 or 8080 or whatever you want to into the main, and that is the port that will be used. Not sure if that's what you meant. Yeah, so you can use port 80, port 8080. In this case, if you don't pass one in, you wouldn't believe how many times you're going to run into conflict with 80 and 8080 around the globe, and so I've just used a value that a port value that hopefully nobody's running when they run this demo. Otherwise, it can be pretty confusing, right? Okay, Frank, is there still time for question? Is there a way to query which HTTP operation are supported on the resource? Great question, Frank. Actually, what you should do is the demos of Vlingo Zoom. So for example, there are a number of Vlingo Zoom demos here, and what we have is when you're using Vlingo Zoom, you can automatically query, and I don't remember what the URI is. Maybe it's just slash, or maybe it's info or something like that, /info maybe. And what you see is you can see the port, the operations that are available, as in the REST operations, the URIs, and you can also ask for open API output, so you can see the generated open API that would correspond to that, so you can document your API. So those are two different URIs, and right now I won't take time to look at it, but I could even find that for you after the afterwards. Okay. Okay, Anders, you say, I mean that 8080 is always used, so using 18080 here is a great idea. Yes, thank you. Yes, that's the reason. And okay, Anders, you like it? Thank you, Anders. And let me see, Frank, thank you. Yes, so Frank, if you have any questions about that, like if you have trouble finding how to list the open API or just the, what does this service offer, you can write me and I'll find that for you. But you should find it in Vlingo Zoom server, I believe it is the let's see. So if you look at Vlingo Zoom server, now you should find that. Now I'm excited about, because we're getting near really advanced use of Vlingo Zoom Starter. This is where you can go into a web interface and describe your service in a number of different ways, and we are generating a lot of sort of skeleton code that will actually compile and run as just with sort of defaults, and then you can go and make any changes that you want. But we actually allow you to tell us what kinds of changes that you're, or what you want your service to look like, your bounded context in terms of aggregates, domain events within those aggregates, the kind of aggregate that you want. Do you want a stateful entity? Do you want to use object entity? Do you want it to be an event sourced entity, and so forth? And do you want to use Docker? Do you want to have a plain non-Docker deployment? Do you want to use Kubernetes instead? And we support all those things. And you may have seen the starter a few weeks ago in one of the webinars, but it's way advanced beyond that now. And we should have a release of that on Monday. So that's going to be with our 1.3 release. That's been a little delayed, but we're going to be there. So with that, I'm going to say thank you very much for attending. It's been a full hour, and I appreciate the great questions. And hey, download Vlingo. Don't forget that documentation is available at docs.vlingo.io. And we'll see you next time. Hopefully we'll have another webinar next week with some more demonstrations of the Vlingo Zoom starter. Okay, have a good day. Take care.